All right, so the Zoom session for chapter 4, as I mentioned before we began, we're going to be going over tasks that are related to the chapter 4 activity, but also the chapter 4 My Lab work as well. We're going to use a set of data that has, it's related to the Super Bowl. So for the first 54 Super Bowl games, I have a data file that has the number of running plays that team used, the number of passing plays that they used, and the total yards that they gained. And what we're going to try to see is whether there's a relationship between the number of running plays and their total yards, or the number of passing plays and their total yards. So the goal is, if we know something about how many running plays they did, can we predict how many yards they gained? That's the main idea we're looking at here. In the chapter 4 activity, you're going to be using some nutritional information, the amount of protein, the amount of fat, and the amount of carbs, to see if there's any relation with each of those three and the amount of calories. And for the data, you can use either information you get from a fast food restaurant's website, or you can look up recipes online that you'd like to make that have nutritional information, and you can gather your information from there. But tonight I've got a set of data that we're going to look at. It's in our StatCrunch group, which is Woodbury Math 21. And the name of the file is Zoom chapter 4. So I'm going to show you first how to get to that. I'm going to split my screen so that we can see that all. All right, so first, to get to StatCrunch, the best way is, if you're already in My Lab, click on the StatCrunch button on the left-hand side, and there are 3 links that'll show up. It's the one in the middle that we want. Visit the StatCrunch website. You can also just go to statcrunch.com. The advantage of going through your My Lab course is that it already logs you in to StatCrunch. Now, if you've already joined the group, you can click on My Groups and then Woodbury Math 21. If you haven't already joined the group, underneath where it says Groups in StatCrunch, click where it says Groups again. And in the search bar, type the name of our group, Woodbury Math 21. And when you press enter, there should only be one that matches that. If you haven't joined yet and you just did that, there should be a blue button that says join this group. If you click that, it'll make it easier for you to get into the group in the future. Once you're inside the group, you want to type in the name of the file that we're looking for. Tonight, it's Zoom chapter 4. And when you press enter, it should be right at the top of the list, Zoom chapter 4. That's going to open up a spreadsheet with 3 columns. The first column is the number of runs that each team did, the number of passes that each team threw, and then their total number of yards that they gained. And again, we're treating yards as the response variable, and runs and passes are the explanatory variables. We're trying to see whether the number of runs impacts the number of yards, or does the number of passes impact them, or maybe both. So that's the goal tonight. When you are doing the chapter 4 activity, and if you watch the chapter 4 activity video, I'll walk you through that. But you'll enter at the top where I have runs, passes, and yards. You'll have protein, fat, carbs, and calories. And then you'll enter the data, one recipe or one item per row. Be sure just to type the numbers. I know, like, for instance, fat is in grams. Don't type the G for grams, just type the number when you do it. All right, so step 1, problem 1 says, compute the correlation coefficient which we use the letter R to stand for that, between runs and yards. So in all of the chapter 4 problems, there are multiple ways to get these done, but you can do them all the same way. And the menu that we should be using is this one: stat, regression, and then simple linear. That does correlation, that does scatter plots from section 4.1, but it also does the regression equation from section 4.2. So it's kind of like a one-stop shopping place. That's the way you should do them all. So stat, regression, simple linear. And in the box, the X variable is going to be the number of runs. And the Y variable is yards. And at this point, that's all we have to do. Click compute. And let me just make this a little bigger so we can see it all. The output page that you're going to get, most of the information that we want, well, basically all the information we want is going to be on the first slide. But if I click the right arrow to move to the second screen, notice it does say 1 of 2 at the top. If I click the right-hand arrow, that gives me the scatter plot. And that helps me to maybe observe the pattern. So does it go up to the right or down to the right? Are they close together or are they far apart? And when I look at this one, this is actually the regression equation. That red line is the line that best describes the data. And we can see that the points are really spread out from there. And that line is almost horizontal. So it's not really a sign that these are related really well, but the evidence for that's actually on the first screen. When we want the correlation coefficient, it's on the 6th line of the output. Correlation coefficient 0.015765 and so on. We usually round that to 3 decimal places. So I've got 0.0157, 0.016 is what it would round to be to 3 places. Now, correlation, the value of R, is always going to be trapped between -1 and +1. The closer it is to -1 or +1, the stronger the relation is. The closer it is to 0, the weaker the relation is. And so I can see here that that number is really close to 0. That suggests that there's little to no relation at all. On the negative side, it means that the points trend downward to the right. On the positive side, it means that they trend upward to the right. But for part A, that's all we needed was what is the correlation coefficient? And there are 2 ways to figure out if that's a strong enough result or not. One is the way that they do it in my lab. Let me just blow this up a little bit. In my lab, they provide you with a table of critical values. And for a sample size of 30, that's the last sample size in the table. The critical value is 0.361. And what we have to figure out is whether our correlation coefficient is bigger than that or not. If the correlation coefficient were negative, you would ignore the negative sign. But here it's positive, so we don't have to worry about it. 0.016 is not greater than 0.361. And that means no linear relation exists. Now, when you do the MyLab homework, that's what they're going to ask you for. They're going to ask you to give your value of R. They're going to ask you to get the critical value from the table, and then you compare them, ignoring the sign. If R is greater than the critical value, they are related. And if R is less than the critical value, they're not. So R less than critical, not related. R greater than critical means they're related. Now, there's a second way to figure out if there's a relation or not. And I think that this is the way that I prefer you to do it when you're doing the Canvas work. And that's to look at this bottom table at the value that's listed underneath p-value. Now, you have to be careful because there are also p-values listed in the top table. We want to focus on the one in the bottom table, which, by the way, is the same as the second one in the top table. We look at that p-value. The p-value is 0.9099. Because that is greater than 0.05, that also means no linear relation. If the p-value is less than 0.05, that means that they are related. If the p-value is greater than or equal to 0.05, that means that they're not related. Now, what I like about this approach is that I don't have to go looking at a table each time, depending on what my sample size is, to find the critical value. Every time I grab this number from that same place and I'm comparing it to the same number, it's compared to 0.05 every time. So the more consistent things are, I think the better off we are when we're working in statistics. So I like that approach better because it's the same exact thing every time. All right, what I'd like you to do is I want you to do the same exact thing, but instead of for runs and yards, I want you to do this for passes and yards. So we're going to come up with three things. You're going to come up with your value for R. Then you're going to try to figure out whether R is greater than that critical value. Oops. And then you're going to try to figure out, is the p-value below 0.05? You want to use that same approach that we just used, stat, regression, and then simple linear. For the two columns, this time you're going to pick passes and yards and click compute, and you should be able to get your results from there. Also, if you've got all your results and you've written them down, take a look at your scatter plot and notice how that appears to be a little different than the one we just looked at. So I'll give you a couple of minutes to work on that. For those of you watching the recording after the fact, you should be doing the same thing, right? Try to do this with passes and yards to see if you can get it. You'll learn a lot more by trying, whether you get it right or not, than by just waiting and passively writing down what we write down. As you're going, if any questions pop up, go ahead and type them in the chat or unmute yourself. I'm going to get it started, but not actually do it. Stat, regression, simple linear. For X, pick passes, and for Y, pick yards. Click compute. You'll get your value of R on that. It'll be about the 6th line down. It'll say R correlation coefficient. And then you can answer those two questions. Another minute or so, and then I'll catch up with you. just press compute. And the first thing I get on the 6th line is the correlation coefficient. It's 0.577 to 3 places. So that's closer to 1 than the first one was for sure. So that suggests that it could be a good relation. When I compare that to 0.361, it is above that. That means that they are related. In terms of the other way of determining that, the p-value, we're going to see this pop up in StatCrunch a lot. This expression less than 0.0001 means that it's basically 0 to at least 4 decimal places. And that is below 0.05. So that also would have told us that these two are related. Now, if we go to the scatter plot, right, these points, we don't see it on the first one, they were all over the place, top left, top right, bottom left, bottom right, kind of no pattern. Here we can see kind of a trend going up to the right. That means the more passes that they throw, the more yards they gain. There's some exceptions to that, like this team threw 50 times, but only got 377 yards, where this team threw like 63 times and 546 yards. So individual values may not all true, but we can definitely see a pattern here that we couldn't see in the first one. On your chapter 4 activity, you're going to do this 3 times. You're going to do this with protein and calories. You're going to do this with fat and calories, and you're going to do this with carbs and calories. And depending on your data, maybe none of them are related, maybe all of them are related. It kind of depends on the data that you have. The last part on problem 1 is going to ask you which of these independent variables is the better predictor of the dependent variable. So on your activity, you're going to try to figure out whether protein, fat, or carbs is best for predicting calories. Here, we're trying to figure out whether runs or passes is best. And in our case, it's going to be passes. And there's a couple of reasons for that. Its value of R is higher than the value of R for the runs. You could also say the p-value is lower than it was for the runs. And in this case, you could even say passes are related to yards. Runs are not. So I think in the example that I did in the video, all 3, protein, fat, and carbs, were all related to calories. So that last option didn't really work, but the best predictor is definitely the one that has the higher value of the correlation coefficient when you do it. All right, any questions on this first page before we move on to look at the regression equations? Again, you can type them into the chat, or you can unmute yourself and say them out loud. All right. The next thing we're going to do, if I pull those results back up, and we look at that scatter plot, this red line is what we call the regression line or the least squares line. It's a line that describes the behavior of the points. And StatCrunch is going to give us what the equation of that line is. So on problem 2, we're going to be finding that equation And then I'm going to give you a number of runs or a number of passes, and we're going to try to predict how many yards a team with those characteristics would have gained. When you do the chapter 4 activity, you're going to find 3 equations, one for protein and calories, one for fat and calories, one in carbs for calories. And then you're going to be predicting depending on which values I give you. So I'll show you an example of that here. So first, in part A, we saw that there was no relation. Actually, let me blow it up for this one. When 2 variables don't have a relation between them, that means we cannot use the regression equation. So here, we're not even going to calculate that. What happened on the first page said that runs and yards, there's no relationship between them. So why would we try to describe yards in terms of something it's not related to? But if we still want to make a prediction about how many yards a team gained, if there's no relation, we're going to use the sample mean, y bar, for the prediction. So this could happen to you on your chapter 4 activity. You may find that maybe fat and calories are not related for your sample. So what we would do to get around that is we go back to chapter 3. We're going to use stat, summary stats, columns. And the column we're going to use is whatever column has your y variable in it, your dependent variable in it, your response variable in it. And so for us, that's yards. Stat, summary stats, columns. Back to chapter 3. Pick the column, yards, and all we need is mean. Click compute. That's about 371.4 yards. And that's actually our prediction for any team. No matter how many times they ran the ball, this would be our prediction, 371.4, because that's the average for all of the teams that we looked at. When in doubt, the average, the mean, is the best predictor. Unless we know that there's a relationship between X and Y, we'll use the average. Now for part C, this pair did have a relation. We saw that passes and yards did have a relation, and so that means we can compute the regression equation. I'm going to use the same steps I did before. This is under stat, regression, simple linear. Stat, regression, simple linear. I'm going to pick passes for X and yards for Y and just compute. And the equation that I need is right here on line 4. Sometimes we're told where to round it. I'm just going to round these to 1 decimal place. So my equation here is yards equals 233.3 plus 4.7 times passes. By the way, in my lab, they usually ask for you to put your answer in the reverse order. This number, 4.7, that's the slope. The 233.3, that's the intercept. My lab usually asks for it the other way. So your equation would look like this in my lab. 4.7 x plus 233.3. You would fill in the boxes that way. But leaving it the way it is in Canvas is perfectly fine. So basically what this says is every pass is worth about 4.7 yards. And then we add 233.3 on top of that result. In part D, now that we have an equation, we can use that to make the prediction. And so we're trying to make a prediction for a team that had 34 passes. So that's going to go in for X, or for passes, in the equation up above. Yards equals 233.3 plus 4.7 times 34. And that number 34, you would have to be given. You know, you don't make up your own number to use there. You'll be given a number. I can go to Desmos, my Desmos calculator, to figure this out. $233.3 plus, I think it was 4.7 times 34. 393.1. That was right. So if we knew that a team had 34 passes by hand, we would predict that they would have gained 393.1 yards. StatCrunch will also do this for us. If we type 34 for predicted, it will do the calculation for us. And let me show you what that looks like. I think oftentimes it's a good idea to look a little ahead in the problem and see if you might need to predict something. You know, look for a value that you're going to be predicting so you can enter it at the beginning. This was under, again, stat, regression, simple linear. I'm going to pick passes and yards. And down here under prediction of Y, this is where I type my 34 for X. When I click compute, it's going to be a little off from the by hand answer that I just had, because I rounded the 233.3 and the 4.7. StatCrunch doesn't round those. And the answer is, we can see if we scroll down just a little bit, when X is 34, the predicted Y is 392.5. So we can see close to what we had, just a little smaller than that. And I would definitely recommend using this. You know, don't leave yourself to chance by using your calculator. Let StatCrunch just do it all for you. It's going to be more precise, and there's a lot less chance for error if you do it that way. All right. Next, we're going to talk about residuals. And it says two teams threw 34 passes each. There's this team that threw 34 passes. They had 338 yards. And there was one more right here. This team threw 34 passes and had 365 yards. If a team threw 34 passes, this is what we would have expected, 392.5. It's asking us to predict the residual for each of these teams. So first, residual is kind of like error. Residual is observed minus what was expected. Observed is what comes out of the sample. Expected is what comes out of the equation, the prediction that we made. And so starting with the team with 338, that minus what was expected, if we subtract those two, let's see, I think that's negative 54.5. What does that mean? It means the team gained 54.5 fewer yards than expected. And actually, let me pull up that last result that we had and go to the scatter plot. Let's see. I'm going to highlight that team so I can see the data on the graph. Let's see, 34 passes, 338. That's the one. That, if we measure the distance to the line, it was 54.5 below it. That's what the residual means. Here's the other one with 34 passes, 365. That's about 27.5 below. And we could calculate that residual by hand, but what I wanted to show you is that we could actually let StatCrunch do that for us as well. Same steps again, stat, regression, simple linear. The X variable is still passes and the Y variable is still yards. I read ahead a little bit and I saw that I was going to have to make a prediction for 34. And I also read ahead a little bit and I saw that I might need a residual. And so if I scroll down to where it says save, I want to pick the option for residuals. And what it's going to do is it's going to calculate those residuals and put them in one column back in the original spreadsheet. So I click compute. Everything looks just the same as what we had. Same equation, same correlation coefficient, same everything. But back on the main screen, there's a new column that's been added called residuals. And if I look at that first team that had 34 passes and 338 yards, there's the residual, negative 54.5. That means that that team gained 54.5 yards less than we expected. Here's the residual for the other 34 team, negative 27.5. So you can get the residuals, especially when you're dealing with a large data set, by just asking StatCrunch to calculate them and save them for you, rather than going and doing them by hand. Real quickly, I did want to go back to that last result, and I want to show you in the scatter plot. Let's pick this point that's clearly above the line. Back in the spreadsheet, it will have highlighted that point for me. This team that threw 35 passes and had 537 yards, there is its residual. It was almost 140 above what we expected. So if the point is above the line, the residual is positive. We got more than we thought. And if the point's below the line, the residual will be negative. We got fewer than we thought. Now on the chapter 4 activity, you're going to compute the equation 3 times. Once for protein, once for fat, once for carbs. In each case, I give you a number to plug in for X to make a prediction. You don't have to, you're not going to be asked for the residuals when you do that. I just wanted to bring that in because this shows up in my lab. So I just wanted to go over that one time with you before you ran into that. All right, any questions on this page? By the way, when you're doing the when you're doing the chapter 4 activity and there is no relation, but you compute the equation anyway, there will be no penalty for that. But you really shouldn't be using the equation when that happens. One last kind of task to do, and that's the multiple regression. So what we've done so far is we use the number of runs to try and look for a relation with yards. And then we use passes to see if we can find a relation with yards. Now we're going to use both runs and passes together to see if there's a relation with yards. This is called multiple regression. Multiple means that you have two or more X variables, two or more explanatory variables, two or more independent variables, trying to predict that one response variable. And so the directions are at the top. You won't find this in any of the other materials that we've done. So we're going to follow these steps. This time we go to stat and regression, but instead we pick multiple linear. For the Y variable, like it has been all day, that's yards. And for the X variable, we're going to select both runs and passes. And this is going to give us an equation that has some number times runs and some number times passes plus some other third constant number. Click compute. And here is the equation. And I'm going to round this to one place. Yards equals negative 8.1 plus 4.7 times runs plus 7.3 times pass. And basically here, that negative 8, that's really close to 0. What this equation is telling me is that these for these teams, they gained about 4.7 yards each time they ran the ball, and they gained about 7.3 yards each time they passed the ball. Notice that the p-value is really low, so it says that this is actually a pretty good fit. We can make predictions, but we can't do it in StatCrunch. So I'm going to finish the rest of this without StatCrunch. Okay, using this equation, we want to predict the number of yards for a team that had 26 runs and 34 passes. So yards equals negative 8.1 plus 4.7 times 26 plus 7.3 times 34. And then we just do the arithmetic on our calculator. Negative 8.1 plus 4.7 times 26. Yep. Plus 7.3 times 34. And now our prediction is 362.3. So the first time we made a prediction, we predicted 392.5 yards for that team. But if we also knew how many times they ran, our prediction changes by about 30 yards, right down to 362.3. When you do this for your nutritional data, I give you the nutrition facts for the Impossible Whopper at Burger King. So I tell you how many grams of protein, fat, and carbs to use in your equation. You do the calculations, and then it tells you how many calories that sandwich has. And we're trying to see how close we got. So here, that one team gained 338 yards. We predicted 362.3. So we were off by approximately 24 yards. But this was closer than using passes alone. You're going to be asked which of your predictions came the closest. The one that used just protein, the one that used just fat, the one that used just carbs, or was it the multiple one that used all three? And the one that used all three should be the closest, because in nutrition, we know exactly how many calories 1 gram of protein should have, 1 gram of fat should have, and 1 gram of carbs should have. And where your individual ones will get a little astray is you'll have some items that are heavy on carbs, but little to no protein or fat. And then you'll have some others that'll be high in protein and fat, or maybe just fat, but not in the others. And so it's a little mixed for if you have an item that has lots of carbs and no fat, there's going to be a lot of calories, but the fat won't be related to that. So the individual ones could be a little jumpy, but when we get to mixing all three of them together, it should be a much better fit. Now, individual results may vary, but you should see that there is a really good relationship when you use all three. All right, any questions on any of this from tonight or anything from chapter 4? And again, you can type them in the chat or unmute yourself. When it comes to working through this activity, the best place for you to go in your class, switch to the student view, just a sec, is if we go all the way down to the week 4 module, there is a video walkthrough for this activity where I walk through all the problems that are on the actual chapter 4 activity, but using my own data set. That semester, I used 10 recipes. Your data set, you need to have 12 pieces of data. So you need to get your own data to do it. But if you watch the video and after I do a step, you repeat the same step with your data, you're going to get different results, but the video will show you how to generate those results on your own. So I think that that's probably the best place to look. I will post the recording from tonight so that you can refer back to this other example as well. But I do think that this is probably the best place to go. One other thing I did mention that I won't be able to host the live Zoom next week, but I've already posted all the materials for week 5. And where it says Zoom pre-recording, the link to the video I recorded and my notes, those are already there for you. So if you get done with week 4 and you want to jump into week 5, which has 5 sections, 5 kind of shorter sections, but 5 sections instead of 2, it'd be a good time to try to get ahead a little bit. Also, even though there won't be a live session, you can definitely reach out to me just like any other week. I'll be online. I'll be keeping an eye on my email, on the Canvas comments, so that if you need any help, I'll be able to provide it. All right, let me stop the recording.